Alright, so I'd like to look at a very strange integral. This is the indefinite integral of 1 over the quantity e to the x plus e to the negative x dx. Now sometimes substituting something right away won't work. So for instance, in this particular integral, substituting u equals e to the x, or maybe using u is equal to e to the negative x, those would be the reasonable first choices. It turns out that neither of those will actually quite do the trick. For this integral, what I'm going to do is actually rewrite this just one more time right here. I'm going to leave a little space for the dx and write this. So what I'd like to actually do with this integral is sometimes what you have to do is do some kind of algebra. And usually the algebra is straightforward. Sometimes, though, once in a while, there are these sort of weirder problems where you have to do a little bit weirder algebra. And here, that algebra will be multiplying by e to the x in both the numerator and denominator. Once you do that, your new integral here becomes e to the x over. Now, when you take this e to the x that's there and you distribute into both of those terms, well, into the first term, you're going to get e to the x times e to the x. You could write that either as e to the 2x or e to the x quantity squared. For what we're going to do, it makes more sense to write it this way, as e to the x quantity squared. I mean, you can try writing it this way, and if it doesn't work out, you can write it the other way. Finally, take the e to the x, multiply that by e to the negative x, and that will just produce a 1. And now in this, it will actually make sense to use u is equal to e to the x. But it wouldn't have been apparent before what to do here. Here then du, well, the integral of e to the x is just e to the x itself. Okay, now this e to the x dx, which is right here, you can actually notice that right here and there. Okay, and then the other e to the x right here will replace this right there. So when we write this integral, you have integral. Now this e to the x times dx, that part we're going to just replace with a du. Otherwise, that's really everything that's in the numerator. So you have this 1 over, and then here you had this e to the x, and then it's being squared. So this e to the x is now u. So this is u. Okay, that's squared, and then you have this plus 1. Now this is a very recognizable integral. Right? This is tangent inverse of u. Okay, then there's a plus c here. The last thing to do to this is to replace the u that shows up right in here, okay, since it wasn't a u originally, using this substitution right there. So if we do that, we'll now have tangent inverse of, and for this u that's right there, we'll replace this with this e to the x right there. Okay, then you have the plus c. So sometimes it's not apparent. This is, I think, one of the harder integrals that you might end up seeing. But sometimes you have to do some sort of thing, some sort of algebraic manipulation before you end up choosing anything to be u. So if you started with the original integral that's boxed there and chose u to be this, you just won't really end up getting anywhere.